Okay, welcome everybody for joining our talk on World Wetlands Day today. I'm Paul Lawrence. I'm the new chair of the Central Branch. I took over from Amy Allwright. So today, Steven Ellery is prepared us a presentation about wetlands. Just a short introduction on to Steven. Steven is a wetland scientist working as environmental consultant in KwaZulu-Natal. He has grown up surrounded by wetlands, as his father is a well-known wetland researcher and educator in South Africa. It is there that he inherited his passion for muddy hands, swirl augers, and stuck gumboots. So he has 5 years of professional experience with ground truth as a wetland ecologist, wetland educator, and drone pilot. So his qualifications range from an MSc in wetland geochemistry and geomorphology, as well as being a registered natural scientist with SACNAPS. Steven also sits on the board of trustees at the South African Wetland Society, where he belongs to the Society of Wetland Scientists, which is an international wetland organization. Okay, Steven, I think the floor is yours.
Amazing. Thank you, Paul, and thank you to the Groundwater Division for hosting me. And it really is encouraging to know that all of you here are giving up your Friday evening to be here to learn something about wetlands and to celebrate World Wetlands Day, which was on the 2nd of February. But I think it's important that maybe we actually just use February to celebrate wetlands as a month. And because, as I hope to illuminate in this talk, wetlands are vitally important to us humans and our well-being. So thanks for being here. It's really great. And I hope that you learned something today. So I'm going to give a brief overview of Southern African wetlands with a focus particularly on their socio-ecological importance. So briefly, I think a lot of us know what a wetland is, but just to highlight that perhaps what we initially and often view as a wetland as a wet, marshy, soggy area full of reeds, just to highlight that actually wetlands are extremely diverse ecosystems. And so in the top left-hand corner, you can see a swamp forest that is full of trees. And on the top right-hand side, you can see a large valley bottom wetland that we might typically associate, that might be our typical association of a wetland habitat. You also get very small, temporarily wet wetlands, like this small depression wetland in the bottom left-hand corner. And then you also get enormous wetlands that cover many, many square kilometers, like this picture on the bottom right-hand side. So they come in many different shapes and sizes and occur in many different locations within the landscape. But how we define them in South Africa and in the National Water Act, we define wetlands as land which is transitional between terrestrial and aquatic ecosystems, where the water table is usually at or near the surface. This is important. Or the land is periodically covered with shallow water, in which land in normal circumstances would support vegetation, typically adapted to life in saturated soil. So just to highlight here that the spectrum or the wetland that is being shown here incorporates both an aquatic environment where there is water above the land surface, as well as habitat that does not actually have water at the surface and is actually characterized more often by subsurface water. So often, again, the thought about wetlands is that there has to be water there all the time. But in some cases, they are either seasonally or temporarily waterlogged soils, and there isn't always surface water associated with wetlands. So to unpack this a little bit further, I have taken this definition and highlighted key phrases from it and related it to the key drivers of wetland formation. So if we think about land, soil, sedimentation, and landforms, we might collectively term those as geomorphology. So essentially, wetlands form in specific areas where the landforms, and processes of sedimentation across those landforms work together to form conditions that are conducive to wetland formation. And often those occur at places where there is either flat ground or there is some kind of geological control that is forcing water to the surface or just below the surface. Hydrology refers to the movement of water through and across the land surface. And so hydrology, as one would expect, is also a fundamental driver of wetland formation in the landscape. And then these two combine often to create conditions that are conducive to hydrophytic vegetation, essentially meaning vegetation that is not afraid of water, so it enjoys growing within water or saturated conditions. And of course, wetlands wouldn't be able to persist in the environment if the climate was not conducive, so if the area did not receive enough rainfall. And there are, of course, other geological factors which would contribute to the formation of wetlands in the environment. So thinking about wetlands, and just to hone in on the point that there are many different types of wetlands, in South Africa, we use what is called a hydrogeomorphic classification system, where we classify systems based on their geomorphic position within the landscape and the hydrologic characteristics of that particular wetland. So how water flows into, through, and out of those systems. And broadly, the currently most widely accepted HGM unit classification in South Africa groups wetlands into 6 different categories or classes, namely channeled valley bottoms, unchanneled valley bottoms, floodplains, depression wetlands, seep wetlands, and wetland flats. So this example on the left-hand side that I showed earlier would be an example of a depression wetland. And the example on the right-hand side might be an example of an unchanneled valley bottom wetland. And here's a schematic illustration of what that looks like in real life. So we have an illustration of a mountainous terrain coming down towards an ocean. And one might find seep wetlands, for example, on the hill slopes that feed into the valley landscape setting, where you would find an assortment or different types of valley-based wetlands, which would include channeled valley bottoms, unchanneled valley bottoms, and floodplain wetlands. And just to, you might also be able to notice that depression wetlands also occur in an assortment of different places and could occur on a bench on top of a mountain, or could occur on a coastal plain, as depicted here as well. So not to go into too much detail about this, because I don't think it's very important for the broader scope of the talk, but just to illustrate, I guess, the diversity of wetland habitats. This is an example of an unchanneled valley bottom. And just to talk quickly through how water often flows into the wetland is either through channeled inputs or through flow that is coming from the catchment upstream. That water then often flows through the wetland in a diffuse meaning widespread and slowly through the wetland, and it often is down a slope, so unidirectional, it always flows down slope. And then how it flows out of that wetland is either through infiltration, so essentially infiltration into the ground, or it will also flow out of that wetland via a channel or diffusely into another hydrogeomorphic unit. And here's an example of a unchanneled valley bottom. Now, this is the Umgeni Flay in the Umgeni catchment. And you can see here, just turn to a laser pointer, you can see here that there's a channeled flow flowing into the wetland, and that channel then disappears around here. And that channel then seeps water into the unchanneled valley bottom. And that essentially flows in a northeasterly direction, in this case, in a very diffuse and slow manner. And just to move on to another example of a wetland, a seep wetland. Seep wetlands are often found in a very different context to unchanneled valley bottoms, and they often occur on hill slopes. And in this example, you can see that, well, seeps are often groundwater fed, or they are fed by overland flow from the catchment. But most of the time, you can see that interflow or flow coming from the ground. There's some kind of geological control that forces water up to the ground surface that creates wetland conditions on the surface. So that's typically how seeps receive water. And then similarly to an unchanneled valley bottom, there is diffuse unidirectional flow through that wetland. And then out of that wetland, there is sometimes channeled outflow, but there's always infiltration. So basically water returns from the surface back into the groundwater table. And here is an example of a seep wetland. You can see that there's no real channel flowing into it, but all of a sudden you see this dark green signature in the landscape, which indicates that there's water there. And that is because of a basically what's called a dolerite sill. So it's an impermeable layer just below the surface that is forcing groundwater to the surface and is creating wetland conditions on the surface of the earth. So to sum this up briefly, what we know so far in the first 15 minutes is that wetlands are unique meeting points of aquatic and terrestrial systems. And they form when specific conditions work together to form ideal conditions for wetland formation. And they are often characterized by slow flowing surface and groundwater, fluctuating water tables, hydric soils, so soils which are represent or have soils that have indicators that they are fluctuating water tables within them, as well as vegetation that is adapted to living in saturated conditions, as well as diverse habitats for biota, for plants and for animals. So maybe some of you are asking, well, so what? Why does this have any bearing on me or my life? Well, wetlands provide us with trillions of dollars worth of ecosystem services completely free of charge. Ecosystem services are essentially, well, I'll explain that just now, but it is no wonder that ancient civilizations, if we think about the Egyptian civilization, if we think about many of the great ancient civilizations, they all started around and expanded from areas where wetlands were plentiful. And quite a neat way of thinking about wetlands is through a socio-ecological framework or lens. So a socio-ecological system describes a set of resources which could be described as natural resources, socioeconomic and cultural resources, whose flow and use is regulated by a combination of ecological and social systems and processes. So scholars have used the concept of social ecological systems to emphasize humans as part of nature and really to stress that the delineation between social and ecological systems is really arbitrary and artificial. And so when we think about human systems in this part of this diagram, what we're really speaking about is societal systems which comprise of individuals, groups, and institutions like governments and companies, and basically societal institutions. And then the other half of the system is the ecosystem in question. And in our case, that might be a wetland ecosystem. But this social ecological system framework can be used to think about a variety of ecosystems and could include grasslands or rivers or forests, and is not limited to thinking about wetlands. And these ecosystems have inherent structure and function as well. And those might be the food web that is at play within that ecosystem, or an inherent carbon cycling system. And so, as can be seen, these two systems have direct impacts or effects on one another. And so actions that originate from the human system, such as agriculture or urbanization, can often have an impact on ecosystems. And then the functions originating from ecosystems can also similarly have an impact on the human system. Hence, I think it seems futile and often pointless, and quite frankly, often damaging to think about ecosystems and social systems in isolation of one another. So let's think about this in a little bit more detail. As I've said, we as humans and our social systems have direct influence and impact on wetlands. And wetlands that are healthy provide a wide range of ecosystem services. But as wetlands degrade, they become less effective at providing ecosystem services. So how do wetlands degrade, and how can we measure that degradation? So wetland integrity or ecological health is often referred to as the present ecological state of a wetland. And that is measured as the perceived deviation from a theoretical reference or natural condition. And that natural condition is a theoretical state, basically that is an unimpacted condition where the wetlands shows little or no impact that is associated with humans or human-derived impacts. So this picture at the top might indicate one that is very close to a very healthy present ecological state score. It looks pretty pristine and natural, not a lot of human interference is happening here. Whereas this bottom picture, I think the opposite can be said. There is enormous pressure on this wetland through litter, urbanization, and extensive use. So one might think, well, why should present ecological state be determined? Determining the present ecological state is central to wetland management and decision-making, and understanding what is impacting our wetland, and potentially how can we reverse or fix those things. It is also a legal requirement for several water resource management processes, such as ecological reserve determinations, water use license applications, and environmental impact assessments. So it is foundational to specific processes within the National Water Act. So it's important that we understand as practitioners, but also I think generally as the public and people who are interested in developing maybe agriculture or urban projects, that this is something that needs to be done as part of those processes. Additionally, assessing the present ecological state of a wetland assists us in establishing a baseline wetland health score for a specific wetland, as well as detecting and monitoring change. So if you come back in 5 years' time and you redo that present ecological state assessment, you would then be able to detect and monitor change over time. And that would then, we would be able to then infer trends over time, which would help us inform development or management decisions around that wetland. So I think we are in trouble if we lose our wetlands. So it was important for us to understand what we have left and what state those wetlands are in that we have left. So this is maybe a little bit technical. I'm not going to spend too much time on this, but remember I spoke about hydrology, geomorphology, and vegetation as the fundamental drivers of wetland formation. And so we measure present ecological state of wetlands essentially by measuring those three components of wetland functionality or health, as well as water quality, which I think in more recent years has become a hot topic in South Africa and has been included in the present ecological state framework and measurement. So so essentially we measure, when we are determining the present ecological state of a wetland, we measure the deviation of each of these four components, the deviation away from their natural state. So essentially before humans had any impact on wetlands. And just to highlight two other fundamental drivers that affect these components would be climate, geology, and I've put fire in there because that has a really big impact on wetlands, and grazing. And actually I should have a picture of humans because we also obviously have a fundamental impact on wetlands. So just to illustrate how this actually works in real life, it's important to think about wetlands not only as being impacted by what happens directly inside them, but it also may arise from within the wetlands catchment. And when I speak about the wetlands catchment, I'm referring to the area upslope of the wetland from which water flows into it from both above and below ground sources into the wetland. And that includes the slopes immediately alongside the wetland, as well as including slopes further away. So essentially this water is, these slopes and the geomorphic landform are carrying water from the catchment or from the slopes and bringing it into the wetland. So if we imagine now that we have a series of developments, you can see here that we have a housing development or a couple of housing developments. There's some farms, so 3s indicate farms, 4 is a forestry plantation. We also have some farms in the wetland. So all of these would be impacting in some way the hydrology of the wetland. So for example, tree plantations are known for using a lot more water from the ground and from the surface than maybe the original grassland that would have been there. So those tree plantations are having a flow reducing impact on the wetland. Perhaps the agricultural areas are releasing fertilizers and herbicides into the wetland, which would also be changing the water quality component of the wetland, as well as the vegetation assemblage within the wetland. And similarly, if you are farming within the wetland, you are maybe redirecting flows within the wetland to make an area arable in the wetland, and maybe you are also releasing fertilizers and other harmful chemicals into the wetland, which would also then be affecting those health components within the wetland. So essentially that is how the human actors can often impact and influence on the ecosystem, the ecosystems in our socio-ecological model. And I suppose it would be remiss of me to mention that, well, wetland rehabilitation is something that happens, and there are mostly 3 reasons why we rehabilitate wetlands. And so those would be to conserve, maintain, and enhance some ecosystem services within the wetland, to conserve those ecosystems, and to protect habitat for species of conservation concern. So absolutely, there is these positive aspects of the human system that can happen on the ecosystems, but often those are treating a symptom of degradation within the ecosystem and not actually addressing a systemic cause of that degradation. So now moving on to how ecosystems can have an impact on humans. So an ecosystem service is any positive benefit that we derive from wildlife in ecosystems, and those can be direct or indirect, and they can be big or small. And so when we think about wetlands, we often refer to 4 broad types of ecosystem services: regulating services, supporting services, provisioning services, and cultural or non-material services. So briefly, what those are. And I know that there's quite a lot of technical jargon in here, but that might be, so in this picture on the left here, that is a floodplain that after a huge storm has collected a whole lot of water and has actually slowed the flow of that water down significantly so that downstream communities, infrastructure, and other ecosystems don't have to deal with a huge flood spike. So wetlands are great at providing flood attenuation. They trap sediment, and they are known as the kidneys of the earth. And so they are very good at assimilating phosphates, nitrates, and other toxicants that humans are putting into the systems. This picture over here is a picture of what is known as peat, which is organic matter that takes a long time to decompose because of the anaerobic conditions in which it exists. And that is a brilliant mechanism for storing carbon. And we all know that in this day and age, carbon is a big source of conversation in the climate change, global warming debate. And so this is just a schematic of how that actually happens. Because wetlands are slow-flowing environments, typically, and often quite flat. Stream flows that come in, which might be polluted, are often attenuated, so the flow is slowed down within the wetland due to the vegetation within that wetland and just the flat nature of those wetlands. And then the vegetation and the peat and the bacteria that exist within wetlands assist to break down some phosphates, some nitrates, and really good at removing E. coli from water as well. And often water that is released from wetlands is much cleaner than how it came in. So that's how wetlands provide regulating and supporting services. Provisioning services are the ecosystem services that we can directly harvest or be extracted from wetlands. So some examples would be water, perhaps food for livestock. People cultivate in wetlands. So many rice paddies in China, Thailand, a lot of those Central and Eastern Asian countries use wetlands to cultivate rice. Even in Africa, Uganda and Rwanda are well known for that as well. Harvesting reeds and resources to make baskets or weaving. So there's actual physical removal of vegetation from wetlands as well. Fishing and food provision. So those are provisioning ecosystem services. And then cultural ecosystem services, which, there's a lot of religious practices around water in South Africa and further abroad as well. So this is how, wetlands have played a role in, the local, national, and global cultures of the world. And I think we also know that wetlands are good places for birding and for recreation and tourism. So we derive lots of cultural benefits from wetlands. And so similarly, how do we assess, to how we assess the present ecological state of wetlands, we also can assess the provision of ecosystem services. So we can assess what wetlands do for humans. And so some very clever people created a supply and demand framework. So the supply is the capacity of a wetland or an ecosystem to produce a service. Maybe that would be livestock grazing or something like that. And then the demand is the societal demand for that service. And those two metrics are combined to create an overall importance score for a wetland ecosystem in terms of different ecosystem services. And so you can see here, if there's a high demand and a high supply or ability by a wetland to supply that surface, there is a very high importance for that particular wetland to provide that service. And so, generally speaking, as the present ecological state of a wetland increases, the likelihood of that wetland being ecologically important or being able to provide significant ecosystem services, there's a general increase. So as we increase the present ecological state, so as we improve the health of our wetlands, generally the ability for those wetlands to provide ecosystem services also increases. However, I think it's important to note that there are still many wetlands with a low present ecological state. They can still provide significant ecosystem services, and we should not overlook those systems as not being valuable to humans and not being worthy of protection and, in some cases, rehabilitation. So I hope that as I bring up this next slide, when we think about a social ecological framework, we can think about the human aspect and how we affect ecosystems, but also what ecosystems do for us, and most of the time free of charge. So in thinking about these human systems and these actions that we are carrying out in the world, these are often driven by much bigger, much more broad drivers. And so I've spoken about physical aspects of a wetland and its catchment that affects wetlands, but I think there's more to that picture. And so part of that might be a lack of political will or capacity to enforce water-related legislation. And that, I think, is a systemic problem in South Africa. Poor governance and a lack of perhaps the ability and, again, the political or will generally to monitor and manage the human impacts on ecosystems. Perhaps there are negative economic drivers which are often global, and those are forcing unhealthy and unsustainable development options. And because people are becoming more and more desperate, there is probably less will to do the right thing in terms of the environment. So poor development decisions are being made as a result of economic drivers. And I think also in our education system, if we think about the agricultural education system in South Africa, chatting to many farmers, for example, and I'm not picking on farmers here at all, but chatting to farmers, there's been no framework or mention of wetlands specifically, but other ecosystems often in their education system and in agricultural schools. And I think that goes for developers and architects and other other land managers or people who have access to land and will develop land. There's not a lot of information around ecosystems and their importance and the need to protect them. And then so all of that, there is cumulative developmental impact. So, one person discharging effluent into a wetland might not have an impact. But if you then start counting the 20 people in isolation who all have permission to discharge effluent into a system, then that cumulative developmental impact is huge, actually. So we keep authorizing specific developments and land uses on a case-by-case basis, and no one's actually really taking the time to look at the bigger cumulative picture, excuse me. And then also cumulative individual impacts. Perhaps I go for a walk or a cycle within a wetland, and I choose the same path to cycle every single day. And actually that impact is, over time, destroying the vegetation and compacting the soil. And that's just a silly small example, but maybe I go for a cigarette break at a wetland, and every day I'm flicking my cigarette butt into the wetland. That, again, a silly example, but is an indication of cumulative individual impacts. So, without making this a doom and gloom webinar, I really hope, and I'm encouraged by so many positive moves that are happening in this country and further abroad in recognizing that actually in this space, the human system, we have so much potential to make positive changes in our decisions and in our collective drive and willingness to change our human systems and our actions towards ecosystems. So first and foremost, I think that we can start thinking seriously about rehabilitation and restoration activities and dedicating time, money, expertise towards that specific avenue of changing the narrative. I think in a lot of education systems, and certainly the one that I experienced in South Africa, a lot of education, and that I've also been a part of as what I do here at Ground Truth, is we educate for awareness, so for people to be aware of the importance of wetlands. But seldom do we ever actually educate people for appreciation, and with that being the outcome of the education. And so I think that's an important and meaningful distinction to make, and so that we can start educating and just involving people so that they become appreciative of natural environments, as opposed to just being aware, because being aware won't necessarily change our behaviors. I think that a lot of our decision making is made from a central place, and I'm not saying that I have the answer to this, but I think that if some of the decision making in South Africa was to be decentralized, and possibly more broadly in the world, to decentralize some of that so that there is more stakeholder engagement. There are, more back and forth engagements between people who are experiencing and having a lived experience around polluted wetlands or rivers. And that engagement actually makes its way up and is informing policy decisions or informing change in legislation, which is actually happening right now. We are busy changing the National Water Act and the National Water Services Act. So it's really important that we mobilize as citizens to make our voices heard in that space. And perhaps there's options to make more progressive economic drivers and systems. So moving away from a completely capitalistic and system towards one that is more geared towards maybe civic action, as an example. And I think that, and so, for example, we are running this enormous citizen science program, and it really is proliferating across South Africa, where there's actually an opportunity for essentially a job pathway where you start as a junior citizen scientist and you work your way up to become an educator and a learner. So it's essentially incentivizing positive ecosystem impacts and actions, as opposed to constantly incentivizing the destruction of the environment and negative actions towards ecosystems. And I think that in land-hungry industries, in the education system like that of forestry or of mining, to have much stronger environmental focus, even if it is just making people aware, but hopefully to then increase that awareness towards appreciation and really educate for appreciation of these natural spaces, so that we are empowering those people who are making those large developmental decisions to think about the environment in tandem with the developmental goals that they might have. And to create and maintain strong civic fields of practice. So the Wetlands Society in South Africa, which I'm a part of, is growing every year. And I think that more and more policymakers, people who are changing the law, are listening to the wetland field of practice. And I think that, just to say that there is a South African Wetland Society, and it's a great way to become involved in talking about wetlands with other wetland people, as well as to start making a difference in the in a broader, much more a broader sense of the country, as opposed to working in small silos of I'm doing my environmental impact assessment and someone else is doing theirs, and we kind of separate it out, to create collaboration and to end this separation that we have in our fields of practice. And then to start also thinking about how we as individuals are impacting ecosystems and wetlands. And so I'm going to end off with just kind of pointing the mirror back at ourselves. And maybe you are a natural scientist. Maybe you are a governmental official who makes decisions around development every day. Maybe you are not related to any of this, but you have a car and you have the ability to recycle and choose where you get your food from. All of those cumulative individual decisions add up to a significant amount. And so talk to your neighbor. If you own land, think about where your wetlands are, if you have wetlands, or what ecosystems remain on your land, which may be providing benefit to other people and to yourself, and you're just not aware of. So yeah, I think just to constantly ask ourselves the question, am I doing the best that I could do for the ecosystems that I am surrounded by and interact with, perhaps unknowingly, every day? And then to end on a light note, just to say that wetlands also sometimes get a bad rap, because we have lots of sayings in the world that are negative around wetlands. So I'm an advocate to changing that narrative as well, and saying, well, instead of I'm swamped with work, I'm actually immersed in nature and I'm having a great time. So thank you so much for listening, and thank you for indulging me on your Friday evening. And yeah, very happy to take questions and engage with anyone who might want to. And please, if you have any questions related to other wetland issues, please do reach out. My contact or my email is there, and my work phone is there as well. So thank you. And Paul, I think I'll hand over to you.
Thank you, Steven, for the interesting talk. It's very insightful, definitely. Myself has been working, or started working in circles where we're looking at constructed wetlands to help us clean up the mess we've made. Okay, everybody, I will open the floor for questions now. You can either raise your hand or you can use the chat box. But maybe I will start off with the first question. It's just How can individuals and communities contribute to the conservation of South African wetlands?
That's a great question, Paul. Thank you. So I think it really depends on where you sit. And obviously, if you are a wetland practitioner, then I think you would know the answer to that. But perhaps as someone who has no real interest in wetlands necessarily, I think just becoming involved in some sort of, or thinking about some sort of environmental initiative and finding one near you that you could contribute to. Because as I illustrated in one of the slides earlier, that it's not only about what's happening in the wetland itself. There are multiple other impacts that are happening far away from wetlands that could be contributing to the degradation of wetlands. So if it's clearing alien plants on a Saturday afternoon with your community, that would be a great way of assisting. And if you I know there are so many river cleanup projects happening all over the country. And I'm sure that those would be quite easy to find as well. And then, other smaller things like carpooling to work, or thinking about recycling, or thinking about where you get your vegetables from and how far they travel to get to your table. So there are an assortment of things like that that could be thought about and engaged with. So I think that without belaboring that point, I think there are an assortment of ways that we could become involved. Also, reach out to the South African Wetland Society. There is a lot happening there as well.
Thanks, Stephen. And I see we've got the question from Chantal Smith. It jumped around. Is there a standard or guideline used to assess the water quality of a wetland?
Sure, that's actually a really good question too, Chantal. So as part of the present ecological state assessment, there is a water quality component to that. And that is based on a land cover modeling process, essentially. And so it's not actually a very quantitative assessment of the water quality of a wetland. So there's no strict guideline or and no strict quantitative assessment that speaks to wetlands specifically. And I think that that is a huge hole in our field of practice. And I know that there are some clever people at the moment who are thinking quite hard about that. And I think that it is important that that is a question that we keep asking ourselves. And as a field of practice, we actually need to come up with a more robust and quantifiable method of measuring water quality, and also speaking to what the water quality should be within wetlands. So that's a great question. And at the moment, there's nothing that is super robust.
Thanks, Stephen. Then we've got a question from Masibuleli. He just said, thanks for the amazing presentation. He just asked, in terms of education and awareness, do we include political figures leading communities, or are we only focusing on communities?
Sure. Also a great question. I think that often we, as scientists and practitioners, we often think about education as needing to go to those people who might not be, or might not have a formal education, or might, in the eyes of the people who are doing the educating, might need or benefit from that education. But I think that where the fault is that a lot of the time those people aren't making the big decisions about development. They're not making the big decisions about where people can put their water, or how they can, the quality of that water that they are being allowed to discharge. So I think in recent times, both the politicians and governmental institutions have recognized a need for that education. And there has been a big drive, in fact, up until recently anyway, for governmental officials to come on various wetland-related trainings. And so I think that the focus is shifting. And with the update to the National Water Act that is happening at the moment, there is also a big shift towards the empowerment and capacitation of decision makers. And so I think that there's a shift. It's happening slowly, but it is moving more towards focusing not only on communities, but also on politicians and people in government.
Thanks, Stephen. I just don't see other questions at the moment, but I can maybe add one question. Just a question, how do invasive species impact the conservation of South African wetlands, and what role do wetlands play in providing habitat for endangered species in South Africa? If you may be able to answer that one.
So I think two parts to that question. The first is alien invasive species. I think depending on the species, they can have differing impacts. So generally, they will invasive species are effective at displacing or displacing other natural species, and so they will then encroach onto and into habitat that would otherwise have been inhabited by native species. So that's the first thing, is that they are displacing indigenous species, and by doing that, they are having an impact on other aspects of the wetland web, as one might call it. They are displacing other animals, and then some invasive species, like some of the bigger trees, like wattles and pines, eucalyptus or gum trees, are also extremely water heavy, and so they consume and transpire far more water than indigenous species. And so it's also a water quality issue, a water quantity issue, where we are losing water to these invasive species and some of these big trees. And then in terms of wetlands providing biodiversity, wetlands are very unique, as I said, meeting points between aquatic and terrestrial systems. So they often have a very unique assemblage of fauna and flora. And so wetlands are unique in that sense, and they are and then wetlands in South Africa also have a high level of endemism being where species are found in that particular habitat that are not found anywhere else in the world. And so they also provide a very important and vital habitat for those kinds of special species of conservation concern.
Thanks, Stephen. I see we've got a question here from the floor from Philip. For wetlands that are of low EIS and PAS, do you think that there is value in replacing these, for example, for development, but replacing and improving their functionality through artificial wetlands or stormwater ponds elsewhere on site?
Thank you, Philip. I think the idealist in me says absolutely. We should try and repair and restore all wetlands, regardless of their state and EIS. Of course, that is in an ideal world and is not always the case. And so I think it is important for us to think about prioritizing the limited funds and time and energy that we have available to us as a community and as a field of practice, and should think about how we can best rehabilitate essentially getting what we would call the most bang for buck. So with the lowest cost, getting the largest amount of wetland restored. And I certainly do think that in increasing yeah, there's increasing talk and interest in this idea of ecological infrastructure and nature-based solutions, which are, of course, artificial or supplemented ecosystems that are, yeah, providing ecosystem services, but they are not necessarily naturally there. They have been artificially created. And I think that absolutely there is space for that. And I think that more and more, as we are losing wetlands, we are more and more looking towards these nature-based solutions and turning perhaps old stormwater drains, which used to be concrete, for example, concrete culverts, into perhaps a reed bed that is slowing flow of water and is also providing water quality enhancement ecosystems at the same time. So certainly, I think there is place for looking at those systems that have low PES, low EIS, and yeah, perhaps transitioning to something that is more aligned with an ecological, yeah, artificial but ecological infrastructure. Paul, I think you're still muted if you are talking.
Thanks, Stephen. Sorry, indeed, I was muted. I think there's time for one more question. I just see we got one coming in from Mahima. How will ecosystem services provision be monitored to determine how these services are being affected by climate change?
Sure.
Did you get that, Stephen?
Yeah, that's a good question. I think that there is a lot of research at the moment going into climate justice and how different people and different communities are being affected by climate change. And a big push in that research field is understanding how climate change is affecting ecosystems and their ability to provide ecosystem services. So at this point, I think that that is an ongoing question that is being answered iteratively, and with time, I think that we would be able to answer that more robustly. But as an example, we know that carbon CO2 is increasing in the atmosphere, and CO2 favors specific plants, and so those plants are growing much more vigorously than others. And yeah, and so we are seeing shift in vegetation compositions in, for example, grasslands or in grassy wetlands towards more trees and more bushy species. And so those kinds of ecosystems are being lost, and the associated ecosystem services that they would provide in their natural state are also being lost because of global climate change. So I think it's an ongoing question that will be answered, yeah, as we move through this climate crisis.
I think the next one's just a quick yes or no question. Is there any current state report of wetlands in the country available? Did you know of, Stephen?
There is a national wetland data set, yes, and it is a desktop-derived spatial layer of the wetlands in South Africa. It is not 100% accurate, and a lot of the present ecological state assessments that have been done have also been done by desktop and using remote sensing. So there's not a very accurate one, nothing like the State of the Rivers report, which we have. So not a succinct all in one place one at this point.
Thanks, Stephen. I think we can start ending the session. Again, Stephen, thanks for your presentation. It was really insightful for me as well. My first time listening to a wetland specialist and on a presentation sitting in. And then I just want to thank as well as all the attendees that offered your Friday evening. I know we South Africans, we like to have a little braai on a Friday evening. So, but I think you can start the fires now and have a cold beer. And then I will just give a thanks to Rolene for the Central Branch. She's one of the young professionals at the branch. She's my right hand at the moment, as I'm still quite new. And also for Ilanda doing all the admin in the background. I think we can conclude. Thanks, everybody, for joining.
Thanks, everybody. Cheers.